Hello, you are most welcome. I'm teacher Ivan from Wuna Educational Services. Wuna Educational Services brings you video lessons through our YouTube channels, that is Teacher Ivan's online class, Wuna e-learning platform, and Wuna Kids platform, where we post children's work. I humbly and kindly request you to subscribe to all our channels. Please comment, like, and share our videos with friends, family members, and colleagues. Otherwise, we are here for another lesson of measurements, and today we shall be looking at derived quantities. Previously, we looked at fundamental quantities, where we looked at mass, time, and length. So if you missed any of those, please look for them so that we move together and enjoy the physics together. Derived quantities. Derived quantities are referred to as the quantities which can be expressed in terms of the fundamental quantities. For instance, we saw that area is given by length squared. Volume is given by length cubed. Density is given by mass over volume, which is mass over length cubed, among others. So these are all derived from the fundamental quantities. And now, let us look at the derived quantities and their units. We shall have the quantity and the SI unit. Let us start with area. The unit is square meter, because when we are finding area is length squared, and the length is measured in meters. So length squared gives us meters squared. The same applies to volume. Volume is length cubed, meaning its SI unit will be meter cubed. So volume equals to cubic meter. For density, we've seen that density is mass over volume. Mass is measured in kilogram, volume is measured in meters cubed. Hence, the SI unit of density will be kilogram per meter cubed. So, density is measured in kilogram per cubic meter. Can add on others. We have pressure. Pressure is given by force over area. Pressure is force over area, and force is measured in newtons. area is measured in meters squared. Therefore, the SI unit of pressure is Newton per square meter. These can also be combined together to have pascals. So we can use Newton per square meter or pascals. We also have speed. Speed is derived from distance over time. Remember, distance equals to speed times time, and therefore if we want speed, we shall divide throughout by time, hence giving us speed as distance over time. Distance is in meters, time is in second, and therefore the SI unit of speed is meter per second. So speed is measured in meter per second, which is we have force and weight, all measured in Newton. If not Newton, what other unit of force? Let us look at how we get other units of force, because force equals to mass times acceleration due to gravity, or it can also be mass times acceleration due to gravity, mass times acceleration due to gravity, or mass times acceleration. This is for vertical motion, this is for linear motion. Now, if mass times acceleration, then the unit of mass is kilogram. The unit of acceleration is meter per square second. Therefore, we can have kilogram meter per square second, or this equal to Newton. So we can measure force in Newton or kilogram meter per square second. So these are some of the derived quantities, and we derive them from fundamental quantities using mathematical formula. In our next lesson, we shall look at some of these fundamental quantities in details. We shall look at area, we shall look at volume. Otherwise, we meet next time. Please don't forget to subscribe, comment, like, and share with classmates, family members, and friends. Otherwise, we meet next time.